Hi everyone and welcome back to my channel in Economist. So in the previous video I have talked about what is L'Hopital rule and we have solved a question on that. Today we will be continuing with that and we'll solve a couple of questions more and then we'll move to some other concepts. So let's start with this. The question says evaluate this particular limit. Now if you observe carefully, again you will see that the numerator and the denominator will be in the 0 by 0 format if you put 2 here. Instead of x, if you put 2, you will see both the numerator and the denominator will be in 0 by 0 format. You can see this for yourself. So again what you have to do, the process that I have shown you in the previous video, just apply that. Consider this. So what will be f prime x? F prime x will be 3x squared. If you know the rules of differentiation, this will be easy for you. Again consider gx as the denominator, 2x minus 8. So calculate g prime x, that will be 2x plus 2, right? Now this particular limit will be exactly equals to limit x tends to 2 f prime x by g prime x according to L'Hopital rule. So find out this limit. X tending to 2, x square plus 2x minus 8 divided by 2x plus 2. So put 2 instead of x, this will be 4 plus 4. Have I made any mistakes? Yeah, I have. Let me check once. Okay, sorry. I have written the expression wrong. Just give me a minute. The numerator will be this, right? F prime x is this, 3x squared minus 14x plus 14 upon the denominator is this. Okay. Now put the values. 3 into 2 square is 4 minus 14 into 2 plus 14 upon 2 into 2 plus 2, right? What will this be? Let me solve it here. So this is 12 minus 28 plus 14 upon 4 plus 2. So you have 26 minus 28 by 6, right? Minus 2 by 6 or minus 1 upon 3. So this should be your answer here. Just check if I have done any calculation mistake and do it on your own. And this is the problem I wanted to give you as a homework. So try your hand at this. Let me know in the comment section what you get. The process is exactly the same. Again, here you will see 0 by 0 form, indeterminate form, and you have to use the L'Hopital rule in the same way. Okay. Now I wanted to discuss a very important theorem with you, which says that let n be any positive integer, then this is one of the most crucial rules of limits, that limit x tends to a, x to the power n minus a to the power n upon x minus a is n into a to the power n minus 1. So this is a formula that you can derive also. If you want me to show you the proof, you can let me know in the comment section. I will do this in other videos. But as of now, you have to, remember this formula because this will come very handy if you want to solve some questions and you will get multiple questions on this. So give emphasis on this formula and try to remember this. Let's see an example how to apply this in our problem. Find all the possible values of n if this is equals to 80 where n belongs to natural numbers. So from this formula, what you can write about this, you can write n into, here n is as it is, a to the power n minus 1. What is a? A is 2 here, right? To the power n minus 1 is 80. Now what you have to do, you have to express 80 in terms of 2 to the power some value and then you have to compare to find out the value of n. So let me do that. 80. So let's see how we can do this. Right? So 80 can be written in the form 2 to the power 4. Here you have 2 4s into 1 5. Right? Here you have 2 to the power n minus 1 into n. Now to compare, what you can do, 2 to the power 5 minus 1 into 5, right? Here you have as it is. So if you compare this, what you will see, n is equals to 5. Do this on your own. It's very simple. You can see it here that n is equals to 5, right? So that is what we tried to find out, that find all possible values of n. So the possible value of n is 5, for which this holds. Okay. So in this way you will get multiple questions on this. So try to remember the formula. And now we will start with limits of infinite functions, particularly in terms of exponential functions and logarithmic functions. These are also very frequent in your exams, so try to remember. This is the Taylor series expansion of exponential and logarithmic functions. You might have seen this beforehand. If you haven't, then you can take a screenshot or you can search it for yourself. Taylor series expansion of all these functions. It's very important and you will find this multiple times. So it's good that you are familiar with this from the very beginning. What is e to the power x? E to the power x can be expanded in this fashion in terms of an infinite series. In this way, 1 plus x squared by 2 factorial, x cubed by 3 factorial, and so on and so forth. Similarly, log of 1 plus x can be written as this, log of 1 minus x and e to the power x, right? You have to, have an idea of this in order to solve the questions, and this will make your life pretty simple. And depending on this Taylor series expansion, we have two theorems which you can also consider as the formula of limits, general thumb rule, which we will prove here, that prove that limit x tends to 0, e to the power x minus 1 upon x is 1. And it's very simple to prove, so I will be proving here. So here you have e to the power x, so just replace what you have here. Instead of e to the power x, write this infinite series. What you have, 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus so on and so forth. Then you have minus 1 here and upon x. Right? Now what you have to do, just divide everything by x. So this 1 will cancel out. Then if you divide, what you will be left with, 1 plus here 1x will be cancelled. So x by 2 factorial plus x squared by 3 factorial plus so on and so forth. Now here in every term you have x, and if you put x is 0, then this term will vanish and you will be only left with 1, right? So this is a very simple proof, but for solving problems you have to remember this thing, or you can remember this proof as well, right? Similarly, another theorem is directly based on this Taylor series expansion, log 1 plus x. Limit x tends to 0. Again, do the same thing, just write the formula. Let me check what was the formula. Yeah, x minus x squared by 2 plus x cubed by 3. X minus x squared by 2 plus x cubed by 3. So it will alternate in sign, right? And this will continue upon x. So this x will cancel out this limit. You will have 1 minus, then after this every term will have x. Again the same thing, right? These terms will vanish if you put x equals to 0 and you will be left with 1, right? This is the proof of this. As a thumb rule, you have to remember these two theorems. I hope this is clear. Now let me quickly do some problems with you. So if you see this kind of problems, you know that limit x tends to 0, e to the power x minus 1 by x is 1. So try to write this limit in that particular fashion. Separate it out, minus you will be left with x by x, right? This will be any which way is 1. So limit x tends to 0, e to the power x. Now for subtraction, you know that you can put limit individually to each of these functions. So here I am not writing the limit because it is independent of x. This will be 1. And from the theorem we saw that this is 1. So 1 minus 1 is 0. So the answer here will be 0, right? I hope this is clear. If you know the formula, it will be very simple to do. And here again, you can also use the L'Hopital rule because this is in the 0 by 0 format. So any formula you can use, you will get the answer to be 0. And here you have another problem. It's a good problem. Limit x tends to 0. Now what you have to do here is that minus 1 here and add 1 here. So minus minus plus 1, right? Then 2 and then separate it out. X tends to 0, a to the power x minus 1 by x. Separate this thing out and separate this thing out. Right? Now you have to find this expression. Now if you remember the Taylor series expansion, I have given you the formula for a to the power x as well. A to the power x is 1 plus x log a plus x square by 2 factorial log a square. Okay. Let me write the value. What was that? Forgot. 1 plus x log a. Right. 1 plus x log a plus x square by 2 factorial log a square, and it goes like this. And then what you need to find, limit x tends to 0, a to the power x minus 1 by x. This is what you want to find. Now if you see the numerator, this 1 will cancel out, right? This expression minus, if you take 1, then this 1 will cancel out. You will be left with only this portion. And now you are dividing that by x. So this x will cancel out. You will have log a here plus the remaining expression will have the x terms, because if you cancel this thing, x will this, it will be have x by 2 factorial and the successive terms will have x. So this will be 0. If you put limit, these terms will be 0. So it will only come out to be log a. Similarly, b to the power x will have the same series. Instead of a, you are just writing b. So what will be this limit? Limit x tends to 0. b to the power x minus 1 by x will be simply log b, right? This is log a, this is log b. And put here log a minus log b. So we will be left with log a upon b. And this will be your answer. This is a good problem. And this is the final question that I want to do with you. It will be e to the power x. Now write this to be this. Okay. This can be written as e to the power 2x minus this will be 1 x into e to the power x. Now all you need to do is to find this format, e to the power x minus 1 by x, because you know that this limit is 1, right? So try to write this in the form of this. What you will get, e to the power 2x minus this, and write 2x first, and then what you do, into limit x tends to 0. Here you have put a 2, so you have to cancel that out using 2 here, and additionally you have this term here, e to the power x, right? Now this value is 1, into you have a 2 here, into 2, into this expression e to the power, here if you put 0, it will be e to the power 0 is again 1. So altogether you have 2, and this will be your answer. I hope you got the process, and this I have given you as your homework. Please do this and let me know what you get. And by this, I have ended everything that you need to know about limits. And if you have any questions about any, portion of this chapter, you can let me know, and I'll try to solve that problem. And if you like my videos, you can give me a thumbs up and do subscribe to my channel for future videos. And thank you for your time.